Alright guys, today's goal, the learner will understand limits and motion in area problems. So we're going to be talking about distance from a constant velocity, distance from a changing velocity, limits at infinity, and the connection to areas, and the definite integral. Like the tangent line problem, the area problem has many applications in every area of science, as well as historical and economical applications. So let's look at some problem that you should be able to do, okay? Computing distance traveled. It says, a car travels at an average rate of 56 miles per hour for 3 hours and 30 minutes. How far does the car travel? Well, change in distance equals change in speed over change in times change in time. So the change in the distance would be the speed, which is 56 miles per hour times 3.5 hours. Remember, think about 3 hours, 30 minutes, 3.5, which is 3.5. So multiply that out, and you would get 196 miles. Okay, let's look at some definitions and things. Okay, when we write the limit as x approaches infinity of f of x equals L, we mean that f of x gets arbitrarily close to L as x gets arbitrarily large. Okay? So, alright, what we have here, do you see how it has an I there? This deals with something called an integral, which is the opposite of that derivative that we talked about yesterday, okay? So, what we're going to be looking at today is it's going to be an integral from 1 to some number, and we're going to talk about how to take the integral of the function x and times the change in x, okay? So, this means, x sub I means the integral. So, let y equal f of x be a continuous function over an interval a to b, a comma b. Divide a comma b into n sub-intervals of the change in x equals b minus a divided by n. Choose any value for x1 in the first subinterval, x2 in the second, and so on. Compute these. Multiply each value by the change in x and the sum up the products in sigma notation. The sum of the products is that. So the sum of that products is the sum of the integral. Okay, so let's take a look at a problem that deals with that. This says, use 6 rectangles to approximate the area of the region below the graph for f of x equals x to the third over the interval of 2 to 5. Okay, so let's take a look at this graph closer. So it said, look at it from 2 to 5, and I wanted 6. Here you have 1, 2, 3, 4, 5, 6 bars. Okay? So what we would do here is if you calculate the area of each of these and sum them up. So if you look, this is approximately, so we see how we can create this graph. Now let's look at the table that helps us give. So see how they say the subinterval is from 2 to 5 halves, 5 halves to 3, the base of the rectangle is 1/2. When you calculate that x value of 5 halves cubed, you get the answers, and then they add them all up. So this area here was the 7.8125, and then this is the 13, and the next one, and the next one, and then you add them together. That gives you the area of the region, the approximate area. It's also known as an integral, using integrals to get that. Okay? So let's look at an example. Okay, So it says use 6 rectangles to approximate the area of the region below. The graph f of x equals cosine of x divided by 3 over the interval 0, pi. See how it says use 6 rectangles? So if you think about this, we need to cut 0 to pi by 6. So because what you would do is pi minus 0 divided by 6. So pi over 6. So we need to think about creating a graph where you start at 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi. And we'll look at the curve. So let's take a look at a graph like this. So here's our graph. Now, notice how these have the bars underneath and the previous graph had the bars above. The previous graph was known as, in your book, I think it's going to be called this. And this one is called this. Okay? But now again, we could plug in the pi over 6, calculate that y value, plug in pi over 3, calculate it, plug in pi over 2, calculate, plug in 2 pi over 3, plug in 5 pi over, and add them all together, and that's the approximate area. Okay? So if we did that, let's see what we would get. If you sum it all up, you should get 2.461 is the area. Units squared. Okay? So see you guys tomorrow. Be ready to go over a lot of stuff in class.